Hi there, I'm Ethan O'Sullivan, and I decided to create a VPN and a network-wide ad blocker from the pre-approved project list. This project was pretty simple, and it didn't require any peripherals, so my challenge to myself was to really do my research and understand what I was doing conceptually here. As far as my rationale for all of this goes, I kind of just wanted to put my money where my mouth is. I'm a cybersecurity student. Concepts like privacy and security should be important to me, and they should be things that I strive for. I know that VPNs can go a long way as far as boosting your overall security on your network, and ads themselves can pose a security risk depending on what kind of ad is being displayed to you. So blocking all ads in general can be a really good way of just like minimizing the kinds of threats that you're seeing. So how does this connect to computer architecture and our overall course content? Well, for the VPN side of things, we learned about routers and gateways in lecture. A router, it receives a packet and it passes it on to a correct recipient. A gateway does the same thing, but it can connect dissimilar networks. If I'm interpreting the guide that I used correctly, I'm actually creating a gateway into my home Wi-Fi from the internet. That makes a tunnel in my network where I can have my own traffic. For the ad blocker, I'll dive into a little bit more depth since this required me to do a lot more outside research. In networking, we have the TCP/IP model, which we covered in lecture. That describes how data gets transported across a network. If you remember correctly from lecture, there are three top layers to the model. At the application layer, that contains something called DNS. Below that is the transport layer containing something called UDP. And then below that is the network layer that contains IP. Those three acronyms are useful for creating our ad blocker. DNS stands for Domain Name System. Conceptually, it's a kind of translation tool that allows a user to make a reference to an IP address without needing to memorize a string of numbers. It's important because we remember meaningful names based on letters better than we remember numbers. You use DNS every single time you look up something on the web. YouTube.com, Purdue.edu, or CDC.gov, those are all domain names. But a network knows those same things as the IP addresses of an organization's server. When you look up a domain name, a DNS steps in to translate. Like we learned at the start of the semester, an IP address is a 32-bit number that can be converted to binary. DNS kind of provides a layer of abstraction between something that's human readable in letter form to something that's machine readable in number form. Once that translation is made, then we can actually talk to the server. DNS is a server in and of itself that facilitates then further client-server interactions between your computer and a website. So naturally, whenever a website displays an ad to you, there needs to be a DNS request for the ad provider's IP address so that the content of the ad can be retrieved from their server. An ad is usually not content that's native to a website, which means that aside from being a general annoyance, it can also be a security risk. What we're essentially doing is reassigning all of the DNS traffic that occurs on our VPN to a new DNS provider called Pi-hole. Pi-hole's DNS has a built-in function that compares every DNS request we receive to a list of commonly known ad providers. If there's a match, then it denies the request. That means that the content can't be retrieved and the ad then gets blocked. The other connection that we want to think about is to file systems. Once we get our VPN up and running, set up on our Pi, and create a new user within that VPN, all of that information gets stored in the configurations directory, which we'll want to be able to navigate. Step one was to designate an open port on my router using a basic network utility tool. That port is where our gateway is going to end up being. I use the default port 1194 for use by an app called OpenVPN, which I'll end up installing on my Pi. After that, I used the curl command on my Pi in order to install an app called PiVPN from GitHub. Once PiVPN was open, it basically acted as an installer for OpenVPN. This is popular enough that the process has been pretty streamlined over time. The installer asks you to declare an IP address, what kind of encryption you want, what port you're using, and who your selected DNS provider is. To make this work, I made my IP address the same as my Pi's, selected port 1194, which I had already made open on my router, and chose 256-bit encryption. I also selected Pi-hole as my DNS provider. Once my OpenVPN was finished installing, I rebooted the Pi to allow it to take effect. And once I was back in, I created 2 new users in order to differentiate between 2 different clients. The first client was called PioSully for my Raspberry Pi, and the second client for use on my PC was called PCOSully. To get access to my new VPN from my PC, I basically needed to use an app called FileZilla. That more or less creates an SSH connection between my laptop and my Pi like we used in lab. And then I can go in there, log into that, and then grab all the file containing all of the relevant login information for PCOSully, and then import that into my computer. I also needed to download the OpenVPN app to my PC itself. I'd already done it for my Pi, but now I was doing it for my PC. Once that was done, I imported the file directly to that app, and that allowed me to log in, and it should have established a connection from my PC to the VPN. But I also have quite an old and outdated router, so I wasn't able to. The guide said that was something to be expected, that he himself, he couldn't get access to it. So that's my theory, that it's just my outdated router. At this point, our VPN should still be functional though, so let's get started on Pi-hole. So since Pi-hole is a server, we need a static IP address in order to run it. My Pi fulfilled that responsibility, so I used its IP address. I also had to select an interface. I was down between Ethernet, WLAN, or WG. I used Ethernet and plugged in my Ethernet cable. Overall, this was also a pretty streamlined and automated process. I was able to see the list of providers that would be blocked and selected how detailed and specific I wanted my reports to be, as that's a component of this software. You'll see what those look like in a moment. So when Pi-hole was done, I literally just had to Google my IP address. When I did that, a page popped up that showed the Pi-hole symbol and a caption that read, "Pi-hole, your black hole for internet advertisements." And then most importantly, there was a link to my Pi-hole admin page for my VPN. That told me I was probably doing something right. I was able to log in from there. In that admin page, I was able to see all of my information about my DNS traffic and all of those reports that I just mentioned. But we weren't quite done yet, because the first thing that I noticed was a little status box, and it told me that my DNS server was down. That's exactly where I started troubleshooting, because that's pretty bad. And that is pretty bad because what we've done is tell the Pi-hole to manage all of my DNS requests. And so if the service is down, that means that no requests are going to get processed. That ultimately means that my Pi couldn't access the internet whatsoever. So fixing this problem was priority number 1. I should take some time now and tell you that everything that I just talked about with installing my OpenVPN, that's what I did the second time around. What I did the first time around was completely different. So the first time around, when I opened the installer, it actually gave me a choice between 2 different options. It was between OpenVPN and something else called WireGuard. I looked it up, and WireGuard is basically supposed to be a much more modernized version of OpenVPN with just better security features, but all around, it tends to be a pretty similar experience. So I thought, hey, this is a modernized, more updated, even better version of what I was going to use. Might as well use it, right? That was a bad decision to make because if you remember, I declared an open port for OpenVPN, not for WireGuard or anything else. I had declared that was going to be my gateway. So I started by trying to reconfigure the VPN. I thought, hey, that's where I went off the beaten path. Maybe I made that unintentional mistake, so let's try it out. Thankfully, that was the key. I reinstalled the VPN, selected OpenVPN this time, and when I went back into Pi-hole, I saw that the internet was working again when I tried to look something up. And more importantly, it said that the DNS connection was up. So I'd succeeded. Thankfully, that was the only major troubleshooting that I had to worry about. So let's see what my project looks like in action. So here's the admin page. I've got it broadcast up here on my TV, on my Raspberry Pi. You can see pretty much the chart of all the queries that have occurred over the last 24 hours. So all of the DNS requests looking for that translation. And then it lists, it says that it's from one client. That checks out because I've only used this on my Raspberry Pi. If I was able to get access on my PC, it would say 2 clients. One thing that's weird is that I have tested this out to see if the ad blocker is working. The ad blocker is working, but the number of queries blocked, it still says 0 and 0% blocked, which is weird to me. But you know what? It might just be a problem with the tracker because I'm certain that the ad blocker is still working. So just to prove to you that it is working, here's this video here of this annoying man. He claims that he's put 100 ads on this video, but he's lying. It's more like 6 or 7. I checked on my PC. But if you see on here, it's 0. So the ad blocker is working on my Pi. We know that much. We just know that the number of ads being blocked is not being tracked. To give you a glimpse at the fact that my VPN is at least slightly functional, we're still on the Pi-hole admin console here. And this page basically gives us a glimpse of all of the different devices where I've connected or tried to connect to this network. And you can see the 3 different devices where I've tried. All of them are red, and none of them I was actually able to access. Which is the fact that they're still listed here is making me think that it's probably a router problem, that I just couldn't sustain that connection, but I at least could make it to begin with. But this gives me confidence that there is some sort of network connection going on. So, in conclusion, were I to do this again, I'd try to improve my security by not using port 1194. The guide said that an attacker can do a port scan, so if you're just using the default port, your virtual private network all of a sudden becomes a lot less private. Doing this project in general has given me a better appreciation for learning with the Pi. What I did here wouldn't really take much more than a button press or 2 on a Windows machine, but convenience really isn't our goal here. This is about education, and when implementing an ad blocker in the past, I never had to learn what a DNS is or how to modify one, and that's a knowledge that I can put to use in much more advanced settings. Thank you.